Good evening, everyone. My name is Peter Germelo. I am the secretary of the York chapter of OACETT. Other team members for tonight's event are our chair at the York chapter, Jennifer Hazelton, Jürgen Friedrich, Jason Lee, and Philia Kung. I'm going to turn off my video now because we have a lot of videos playing, and to ensure that they play as smoothly as possible, it's much better if I disable my video, but rest assured I'm here and I'm a real person.
OACETT stands for the Ontario Association of Certified Engineering Technicians and Technologists.
OACETT really provides kind of that benchmark for people that are just starting out in their career that employers are looking for.
As I progressed in my career and I became a hiring manager, I realized as well that it's easier for me to choose OACETT certified members because to me I find that they're pre-vetted.
This gives them a solid background to engage in their pursuit of employment.
I quit a very well-paying job to go back to school, and I was very afraid. OACETT really gave me the confidence to just charge forward in my career.
OACETT has been a great forum for me to develop confidence in being a woman in technology, and I would say to a young woman that this is one of the most, being with OACETT and being a part of the system is one of the most valuable things that they can do for their career.
In my 25 years of experience, I can truly testify that having OACETT certification enhances your credibility within the engineering profession.
And the education tells an employer that the person has read and understood the literature. The certification tells an employer that the person has applied that knowledge effectively.
And at many times, it becomes the minimum criteria that's required to compete.
If somebody asked me the question straight up, I'd say yes, we get paid more, and we deserve to be paid more.
Networking is great. OACETT provides unlimited opportunity for networking.
That's huge to me, because if you don't have any networking, you're not bouncing any ideas, I think you're limiting yourself.
I can pick up the phone if I have a question on an electrical system, and I can get an OACETT certified member to provide me advice, guidance, and their expertise.
I would say one of the best reasons to network is to get a job. I mean, in my personal case, there isn't a single job that I've gotten that hasn't been solely because of networking.
As an employer, knowing that CPD is mandatory offers us a sense of comfort.
Well, the continual professional development is an important part of anybody's career, whether they're certified or not. You don't want to get stagnant in your career.
It ensures that the employees continue to stay relevant in their field and they continue to educate themselves so they continue to be the best in the industry.
While we meet today on a virtual platform, we begin by acknowledging the Indigenous peoples of all the lands that we are on today. We do this to reaffirm our commitment and responsibility to improving relationships between nations and improving our own understanding of local Indigenous peoples and their cultures. We encourage contemplation about the current relationships between Indigenous and non-Indigenous communities as First People and as Canadians. Since our virtual engineering challenge was open to residents of all Ontario, the list that appears on your screen represents First Nations communities from all over Ontario. My apologies if there are any unintentional omissions. Here is the agenda for this evening's event. I will begin with a quick welcome message, followed by a brief introduction to engineering and engineering technology. We will then play the videos that were entered into the virtual engineering challenge for all ages, beginning with the grades 1 through 4 group and ending with the college and university groups. The challenge for the young professionals group was different than the other groups. The young professionals challenge was to create a presentation for each of the other groups to teach them about the engineering principles involved in their own challenges. So there will be a young professionals video played with each of the other groups. After all the videos have been presented, we will address the competition portion of the event, the voting, and the awards. The final item on the agenda are closing remarks. We have muted all microphones and disabled all cameras to ensure the best possible video playback. Welcome. Welcome to the first virtual engineering challenge for all ages. I would like to say a big thank you to all of the people of all ages that participated in this event. I would also like to thank National Engineering Month Ontario and the York chapter of OACETT for their support in making this event possible. Last, but definitely not least, I would like to give a special thank you to Jürgen Friedrich, Jen Hazelton, Jason Lee, and Philia Kung for all of their time and effort helping me to organize this ambitious event. Again, all microphones and cameras have been disabled in order to provide the smoothest video playback possible. If you have any questions during the event, please use the chat function in Zoom, and our chapter chair, Jen Hazelton, will try her best to answer them. Introduction to engineering. I would like to start off by explaining a little bit about engineering. When I was a boy, the only thought that would go through my head if I heard the word engineer would be a train engineer. Now that I am older, I have realized that I still don't even know all the different types of engineers because there are so many. The word engineer comes from the Latin words ingenium, which means cleverness or smart, and ingeniere, which means to devise or design. So an engineer is a smart person that designs things. A lot of people sometimes confuse science with engineering. Science tries to understand the world by doing experiments and gaining knowledge. Engineering uses the knowledge that science finds to design something that solves a problem. Depending on what kind of problem, a different kind of engineering is used, and many times a problem will need many kinds of engineers to solve it. Think of the computer, tablet, or phone that you're looking at. Many different kinds of engineers were used to design it. Electrical engineers, electronics engineers, communications engineers, computer engineers, software engineers, perhaps even environmental engineers and mechanical engineers. There are so many different kinds of engineers that it would take too long to list them all. So I encourage you all to do a bit of research and you will see what I mean. Now we have a better understanding of what an engineer is. I want to talk to you about what an engineering technologist is and what an engineering technician is and how they relate to an engineer. All of these people, the engineer, the engineering technologist, and the engineering technician are on the same team to solve problems and design things. However, what they do for the team is different, and it requires a different amount of school. An engineer takes at least 4 years of university where they learn all the complicated math needed to solve every kind of problem. Engineers use these complicated maths on the engineering team to solve problems and design things. They produce the blueprint that the engineering technologist and technician use to build the design. Although the engineer receives the greatest reward from the design, they are also more responsible if something goes wrong with the design and somebody gets hurt. An engineering technologist takes at least 3 years of college where they learn some of the complicated math needed to solve problems and also learn some of the ways to use special tools and their hands to build the designs from the engineer. Engineering technologists use some of the complicated maths to figure out how to build the design by reading the blueprints and using special tools. An engineering technician takes at least 2 years in college where they learn a bit of the complicated math, but learn a lot about how to use special tools and equipment to build and maintain designs. The engineering technician is the one that usually assembles the final design. That is how engineers, technologists, and technicians work together on the same engineering team. As I mentioned before, there will be one video presentation from a young professional, Sid Ali, for each of the other groups. The purpose of these videos is to teach the different age group about the engineering principles associated with the other challenges. The first challenge of tonight's event is the Build a Tunnel challenge for grades 1 through 4. This was a challenge to design and build a tunnel using a variety of different materials, encouraging creative problem solving. There was only one video submitted for the tunnel challenge by, and excuse my pronunciation if it's wrong, Thelai, age 10, or Thelai. Here is the presentation.
This is the tunnel I made. It uses the cut and cover technique. It has popsicle sticks. The popsicle sticks are there to reinforce this tunnel. The popsicle sticks are kind of like the tunnel's skeleton. I have an LED light in this tunnel. The LED light is there to illuminate this tunnel. I also have a drainage system in this tunnel. The drainage system is there to take out all the water from this tunnel. And I also have 2 pipes, one on each side. I have 3 pillars. The pillars are there to ensure the top of this tunnel doesn't give in. I have a ventilation system. The ventilation system is there to take all the fresh air from outside and bring it inside. All the heat, which is already in the tunnel, goes outside through this ventilation system. I have signs on this tunnel. The signs are at the sides. I have 2 packs. They are for the maintenance workers. I also have small black pieces of construction paper for track ballast. The track ballast is there to ensure the train tracks doesn't move.
And here is the young professional's video presentation for the tunnel challenge.
Hello, my name is Sid Ali, and welcome to my presentation on tunnels. How would you get past this mountain if you saw it? Option 1 might be just to go around, which would probably take a lot of time and might be difficult. Option 2, make a tunnel. A tunnel is a hole that is dug through or under an object, like a mountain. Other types of tunnels are used for mining or transporting water. What are tunnels used for in modern times? They're used for trains, underground subways, and for cars to drive through. For tunnel design considerations, tunnel designs can depend on the materials they meet. If it's soft ground, it might be easy. Soft rock might be more difficult. Solid rock would be harder. And underwater might be the most difficult. What kind of engineers work on tunnels? Structural and civil engineers are key to planning and making sure the hole is dug safely. And they're important in making sure the workspace is safe for everyone. Other engineers that can work on this project could be geotechnical, mechanical, electrical, fire, and more. How are tunnels made? Boring? No way. A massive boring machine can be seen on the right, and that's what's used to drill a hole. Some tunnels were made with explosives, but people can be hurt, so they have to be extra cautious when they're making them. And for activity time on tunnels, next time you make a sandcastle, try and make a tunnel underneath to the other side. That's the end of the presentation, and have a great day.
The next challenge for the grades 1 through 4 group is the Marble Maze Challenge. For this challenge, the contestant needed to design and build a maze with various suggested materials so that a marble could roll through to solve it. There are 3 entries for this challenge, and our first video is from Austin, age 8.
Hey guys, my name is Austin Blanche. I built a marble maze out of a pizza box, popsicle sticks, and glue. So first I got the pizza box. Then I got this around here, but I didn't cover up 2 spots for the entrance and the thing, and the exit. Then I put some obstacles to make it a little bit harder. Then after I put all of the obstacles right here, I started making some holes because it would be too easy over there. That's why I started making it harder in doing it. But then I figured, how would they come out? So I just did that right there. So see that? Right there? It's gonna come out now. Pieces. So that thing was supposed to come out. Okay, there it is. So it comes out right there, and yeah, let's go one, see how it goes. Okay, first try. Worked. So, if it cuts, let's try. Just do it. Yeah. There it is. So, thank you guys so much for watching.
Our second video submission is from Cole, age 8.
What makes it easier if you find a path, like in a video game, if you find a path that's the wrong way, and if you mess up, you have to restart, you know which way you have to go, so you go the other way. It can use more than one kind of material. You can use straws, tin foil, you can use rocks. I am going to use like straws, like these. We're gonna put it right in here. Marbles! I'm rethinking. I'll erase this. I made 3 more dead ends. I made another new dead end right here. So when you start here, go here. Here, you can rather go here, which is the good way, or you go here. Use cardboard strips. I'm making the way to the first dead end. I erased it because it wouldn't work, because this is too small. I used cardboard strips and glue. Yeah, I made some dead ends, so I made some tricks like here. Made a trick here. Made another trick here. Trick here. I made a lot of tricks. Made a trick here. Here is the hard part. You have to get it right. You have to roll the marble to here by doing this.
Our third video submission is again from, pardon my pronunciation, Thelai, age 10.
This is the marble maze I made. The entrance of this maze is over here, and the exit is over here. There's dead ends in this marble maze. Also, the marble has a long path to go because there's a lot of places where you can get stuck. Now, since I'm closer to the end, I have two paths to go. I can either go here or here. Since I choose this path, I get to the finish line.
Good job by everyone for that challenge. The next challenge in our competition is a life cycle analysis for the grades 5 through 8 group. In this challenge, the students were asked to develop a rating system for various household products based on the raw materials used to make them and the ability of these materials to be reused or recycled. We have two video submissions for the Life Cycle Assessment Challenge. The first submission was done by Inian, age 12.
This is my scoring system and the scoring of the items. How to score. The difficulty of the extraction will be worth 10 points, with 10 being the easiest and 0 being the hardest. Availability will also be worth 10 points, with 10 being the most and 0 being the least. The likelihood of being recycled will be worth another 10 points, with 10 being the most likely and 0 being the least likely. The maximum points are 30 and the minimum points are 0. Lined paper has a score of 27, the wooden desk has a score of 25, ruler has a score of 24, the upholstered bed has a score of 22, paper tape has a score of 22 as well, mattress has a score of 21, laptop charger also has a score of 21, the computer mouse has a score of 19, the eyeglasses have a score of 18, and the laptop has a score of 16. The reason the lined paper is number 1 is because the material used to make it is easy to find in Canada and to a certain extent renewable, and it is also readily available in Canada and has a high likelihood of being recycled. On the other hand, the laptop is last because the materials used to make them are non-renewable and as an electronic has a low chance of being recycled. Some ways to reduce the environmental impact of manufactured goods are to use recyclable, recycled, or repurposed material, so there's less waste going into the environment. To use factories where the energy source is renewable, such as solar power and hydroelectric power, and to use materials that are readily available. And what I mean by that is that like materials that are not under strain. And the reason a life cycle assessment is a useful tool for engineers is because it can help the engineer find out which products are good and bad for the environment. It can also help have more buyers for the product, since there is a growing movement to buy more products that are environmentally friendly.
Our second video submission for the Life Cycle Assessment Challenge is Priya, aged 11. I'm not sure why the picture is upside down now, but the video seems to be correct. There was some kind of glitch with my software.
Hi, my name is Priya Smyrnis. I am 11 years old and I live in Toronto. I did the Life Cycle Assessment Challenge question. My objects are light bulb, tape, cable, clock, computer, water bottle, bike, pen, and scissors. My ranking system is based on a scale of 1 to 10. So, for example, if the object was 53% recycled, in my system it would be 5 out of 10. For my objects, I wrote down the scores of the materials to make the object, using my ranking system. Then, I made an average of the object by adding all of the material scores together and then dividing it by the number of materials. Then, with the averages, I ranked them into 3 lists: extraction, availability, and recycled. So, on the list extraction, the rankings are from easiest to get to hardest to get. So it goes tape, computer, clock, pen, light bulb, water bottle, scissors, bike, cable. On the availability list, from most of to least of the material, it's light bulb, clock, tape, scissors, computer, bike, pen, cable, and water bottle. Now, on the recycled list, it's from most recycled to least recycled. Light bulb, tape, cables, clocks, computers, water bottle, bike, pen, and scissors. Some ways to reduce environmental impacts of products are for one-use things to be made to be biodegradable and the other things are recyclable. Life cycle assessment is a useful tool for engineers because they can find out how long something will last. The end. Thank you.
The second challenge for the grades 5 through 8 group was the Build a Boat Challenge. In this challenge, the students were asked to build a boat out of various suggested materials such as paper, straws, tape, and plastic wrap that could be built to support 10 nickels for at least 1 minute. We had 4 submissions for the Build a Boat Challenge, and our first video is from Chase, age 11.
Hello, my name is Chase. I'm 11 years old and I am entering the engineering challenge for all ages. It's the Build a Boat. So right here, this is my boat, and I went for a wedge design instead of a raft because I felt if you put straws on the side, then it would balance kind of well. And I also put saran wrap on my thing to make it waterproof. Now this is actually my second attempt. The first attempt, it was the same thing, just without the straws. And I felt like if I had the straws, it would be another layer to actually getting to the actual boat, instead of just it being the actual boat, and then the actual boat will have to sink. Because paper straws are somewhat waterproof. And the way that they're apart, I don't think that it's gonna Maybe this side will fall in, but who knows. Okay, so I'm going to put it in. It's just floating. The saran wrap is kind of holding it up, but let's just say people can't really ride in this boat. Now the way I'm going to position my nickels, I'm going to put them even, and some in the back and some in the front. So all across and some in the back and some in the front. Or I might just put it all in the back so it will be vertical or horizontal. See how I'm putting some in the front and then some in the back, and they're all spread out. Okay, yeah, I see the boat is turning. It's getting a little bit, it's getting a bit, like straight. And I can see that I hope when it goes straight, straws can keep it up a little bit. And the saran wrap is doing what it was really meant to do, keep the boat afloat and make it waterproof. Because if the boat gets soggy and gets wet, it's just going to sink because it adds a lot of weight because the boat absorbs the water. Let's just see. It's not really moving around. It's kind of stationary. It's almost like it's an anchor. Very, very weird. I think that it kept afloat. And that is my engineering challenge. Of all ages, to build a boat. Thank you.
Our second submission for the Build a Boat Challenge is from Eric, age 11.
Hello, my name is Eric Robert and I am 11 years old, and today I'll be telling you about my two boats. So, my first boat was not a great success because it didn't really have a lot of surface area, and it only held like 13 nickels. And what I learned is you need more surface area, and you need more plastic wrap, and you need longer straws, because if you just do one straight line, then it won't have that much surface area. So, but my second boat was a huge success. It held 90 nickels, 12 loonies, 1 toonie, and 2 silver dollars, and 40 marbles. So I was surprised that it even hold 90 nickels. So on my first attempts of putting this in there, it was good. And then my third attempts, we put the marbles on, but it started to do this. But since I have more surface area and longer straws, it increased the chances of the boat actually surviving and floating. So that's my boat. Thank you for listening. Bye.
Our third submission for the Build a Boat Challenge is Jackson, age 11.
The boat challenge. Probably a raft,
considering it'll have the most space for the coins. Centimeters long and 5 centimeters wide. I'm not done yet, but I'm doing a drawing with the paper straws, and there's the demonstration with the coins. The bottom will be made of paper straws, and it will be because paper straws are paper. They're just gonna get wet and sink. So I'll be using I guess you could say medical tape because medical tape is stretchy and thick. You could probably use it to keep it afloat. So the first test is to make sure it's close.
Oh.
Okay, so close. Perhaps because of the straws in the center. When I taped it together, it probably kept a bunch of air, meaning it has a lot of buoyancy. So it probably stays afloat because of the air inside, allowing it to, because the air has buoyancy. With buoyancy, it floats with lots of points.
Our fourth submission for the Build a Boat Challenge is from Inian, age 12.
This video will show the differences between my original design of my boat and the improved design of my boat. This is a part of the video of the original design. And this is a part of the video of my improved design. My improved design was able to hold more coins and more weight because of its larger area. My original design was able to hold exactly 50 grams, while my improved design was able to hold 112 grams. My improved design is also more streamlined. My improved design has sides which prevent the coins from going over, while there's a higher chance of the coins going over in the original design because there are no sides.
Here's the Young Professional video on Marine Engineering by Sid Ali.
Hello, my name is Sid Ali, and welcome to my presentation on marine engineering. Buoyancy. No, it's not just a funny way to say Beyonce. It's another way of saying how things float. So how does buoyancy work? It is an opposite effect to gravity in water. So when the weight of an object is less than water, it floats, like that rubber ducky. Hull designs. There are two main ways ship hulls are designed to move water either around them or ride on top of water. Bigger boats cut through the water and displace or move waters around them. Smaller boats use planing hulls to skip across the surface at high speeds, as you can see in that photo. Types of hulls. Flat bottom hulls are very stable and used for fishing. Round bottom hulls are designed to move through the water easily. An example of that could be a canoe. V-shaped hulls are used in smaller boats for planing, and they are the most common and usually have very powerful engines. Mid-chine hulled boats are broader and have an increased area, which helps them to be stable, but because they're wider, they're more difficult to steer. For different ways to power a boat, on an outboard engine, as seen on the right, it's mounted outside the boat's hull and can steer by turning the direction of the motor. These are usually seen on smaller boats. Another way to power a boat is using an inboard engine. These are found inside the hull and uses a small car engine to power the boat. It is steered using rudders, which direct where the propeller jets are going. And lastly, the last way to power a boat is using a stern drive engine, otherwise known as an inboard-outboard engine. It's similar to inboard and outboard engines in that it uses a small car engine to power the boat, and like an outboard engine, there is a device used to steer the boat that moves the direction of the motor. So activity time. Get a bucket and fill it halfway with water and drop in objects to see which ones sink and which ones float. Try a bottle, a small rock, or see if you can make your own boat out of aluminum foil. Thank you, and have a great day.
Unfortunately, we did not have any submissions for the high school group. I guess everyone was too busy playing video games. However, since our young professional, Sid Ali, went to the trouble of making this presentation, we will show it to you as it is very informative. This challenge was to make an airplane launcher. Here is Sid's presentation on aerospace engineering.
Hello, my name is Sid Ali, and welcome to my presentation on aerospace engineering. So the basics of aerodynamics. There are four forces that affect aerodynamics: weight, thrust, lift, and drag. What is weight? Weight is the mass of an object under gravity. What is lift? Lift is airflow that pushes an object upward with a greater force than the weight. What is thrust? Thrust is the force that propels an object in the direction it is moving. And what is drag? Drag slows motion, and it is the opposite to thrust. What propulsions are used? Propulsion systems are made to either balance the drag and thrust, making the plane cruise at a certain altitude, or to have the thrust exceed the drag to accelerate faster and possibly increase altitude. Examples of these are propeller planes, which are better at maintaining cruise speeds and are found on cargo planes, or jet propulsion planes, which are found on smaller planes. They use gas turbine engines and are used for very high thrust speed acceleration. Space design considerations. Do wings work in space? Not like on Earth, because there is no airflow to aid in aerodynamics, which is why rockets are mostly shaped with a conical nose structure to pierce through the atmosphere. The rocket can then break into stages depending on what it is trying to accomplish. And the atmosphere of space is a vacuum which doesn't have any factors that can affect drag or friction on an object, so an object in motion will stay in motion, unless it's affected by the gravity of another object in space, such as a planet or the moon. Further learning. You can find good resources for aerodynamics and space exploration through NASA. They have guides for beginners up to professionals to learn from. Thank you for joining me, and I hope you enjoy this presentation.
Our first challenge for the college and university group was to use the electricity bill from their household to figure out the size of the PV solar system required to power the house. Renewable energy is an emerging market, and it's very important in combating climate change. We had one submission for this challenge from Param Tavala.
Hello, hope you are doing well and safe. My name is Param Tavala, and I will be talking about my design of a solar panel system in my household. So this is just a basic design, on-grid, meaning that we just need to calculate the size and number of solar panels. So in this design plan, first we calculate our daily kilowatt hours use, then we calculate all our electrical loads, then go find our number of solar panels and find the area need to place the solar panels. So on this slide, I actually went on one of our bills and find out the actual kilowatt hours usage. And that's for the period of 30 days. And I just divided by 30 and find for 1 day. And that's for daily use. And that's similarly for power use, meaning wattage. So here comes the most fun part of the whole design, finding the all electrical loads in our household. So I literally go and check out the all power that is written on the devices. And some of the devices didn't have that written on them, so I looked up on the internet and add them all up together and find the whole maximum power demand, which is roughly about 32,000 watts. And daily maximum power is about 755 or 756 kilowatt hours. For final calculations, we just simply need to find the kilowatt hours for solar panel, and that's simply multiplying our power 250 times 5 our sun hours and divide the whole thing by 1,000. That's the formula. And we get 1.25 kilowatt hours for one panel, solar panel. Then we add up our daily usage kilowatt hours that we find on our bill and add it with our daily maximum power demand we found on our electrical load in our household. And we find the number 767.44. We divide this number by the whole product of 1.25 times the efficiency, which is 0.2. And the number of our panel would be roughly this big number, and we have to round it up to 3070. To find the area, we just simply multiply the whole area, 1.64, times the number of panels, and we got 5,025 meter square. And the question is, why these numbers are very huge? And I have to answer that that's because we consider to use 100% of this energy to use from our solar panels, and that's why we have to use many solar panels.
Our second challenge for the college and university group was to design a cup holder using Tinkercad, which is a free 3D modeling software that's available online. The design was to take into consideration the materials used so that it could be 3D printed. We had 2 video submissions to the Designing a Cup Holder Challenge, and the first is from Jagveer Singh.
Hello there, my name is Jagveer Singh and I'm here with my design wristband cup holder. So let's get started. So right here on the left hand side you can see that I have my design. The band is made up of flexible filament, whereas all the other parts are made up of ABS plastic. Let me describe what exactly are the materials used. So as I just said, ABS plastic is for all the other components, which is roughly $56.89 Canadian. The entire filament roll, which weighs approximately 1 kg, you can see right here, and also the filament for the wristband, which is just this much, so which costs about 44 bucks, and the 44 bucks is for 0.8 kg. If I talk about that why am I going to use this material, the benefit is that ABS plastic is for overall parts and the filament for the wristband. The benefit is that it is lightweight in material. It means that you won't feel a lot of weight while you are carrying everything, and also it is pretty cheap in comparison to all the alternatives that are available in the market itself. If I talk about the total weight, it is 203.258 grams. You can see I've done the calculations itself, and roughly on average, if I say, it is roughly about 204 grams. And if I do the calculations, so $50 per kg is based on all these, that how much on average of 56.89 with 44.47, which is approximately $50 Canadian. And if I do rough calculation based on that, then I'm going to have estimated cost of $10.2 Canadian per product. So the entire product can be made in $10.2. So let me show you how it works. So you can see that the actual any cup holder that you want to keep, you can put it inside this cup, and you can see that it is flexible to move. Similarly, you have the flexibility to retract and extend the part that you want to. So this is just a visualization that I want to show, the simulation of it, and it's pretty cool that you are able to adjust the length according to the individual need. So why I choose the design? First and the main thing is that it helped me to free up one of my hand, or that will help you to have kind of three hands to do extra activities that you want to. The looks are really good and hence it is aesthetic, lightweight and easy to use. The functionality is pretty simple. Retractable design allows you to compress the part and it becomes like pretty compressed as well, so it doesn't seem much tidy. Thank you for watching.
The second video submission for the Designing a Cup Holder Challenge is from Mohammed Aref Nasiri.
Hello, this is Muhammad Arif Nasiri. I study automation and robotics in Centennial College. Here I'm going to explain about my designing for a cup holder. So basically, what do I expect from a cup holder? First, in some situations I need to put my cup of hot coffee somewhere and just let it get cold. So it must be able to withstand high temperatures. Second, it should take it in a stable situation. Imagine you are in your car and you want to fix your cup of coffee somewhere. And the last one, it should be just fix the cup of coffee, not something larger. The first part of designing is cup holder's leg. It is support for whole holder, and also it maintains its balance and the cups balance perfectly on flat surfaces. Before I go to next part of designing, I should mention something about gyroscopes. Gyroscope is a device which measures the angular velocity and also its electronic versions determine the direction of robots and also maintain balance in specific situations. Now, what about situations that the cup holder is not on a flat surface? I designed this part like a gyroscope. As you can see in the picture, this part consists of two rings, and these rings are connected with two pins to the leg and let the cup move in two relevant axes to be in its stable situation. The final design is something like this. Because 2/3 or half of the cup holder's height is in the inner ring, and due to the gravity, the cup would always be perpendicular to the ground, and with any fast movement it wouldn't change its situation. You can see two situations that the cup holder would face some fast movements in this slide. There are two types of materials that we can use for making this cup holder, PLA and ABS. Both of these materials are available in filament form that we can use them for any 3D print device. PLA is biodegradable and made by, for example, corn, but ABS is made with chemical materials. Both of these can be recycled, and we can use them again by melting them. But I should mention that ABS is more strong and durable. My presentation is now ended. Thank you so much for your attention.
The final video presentation from our young professional, Sid Ali, is aimed at the college and university students. Sid was tasked with explaining his personal path in engineering and to offer some advice to students that will soon start a career in engineering. Here is his presentation.
Hello, my name is Sid Ali, and welcome to my presentation on my personal path in engineering. My career journey began when I studied biotechnology and industrial microbiology as a technologist straight out of high school. I then attended a bioinformatics diploma program, which is programming for genetics-based industries. I did this because it included two of my interests, which were both computers and genetics. I worked for a big corporation for almost a decade as a data manager, and then went back to school for energy systems engineering as a technologist, as I felt pivoting to a new career in energy systems with renewables in mind was forward-thinking. In my final year, I joined OACETT for networking and professional growth opportunities. This included volunteering for events in my area and trying to learn from the groups I'd be working with. In a diverse group of engineers, you can always learn something. Presently, I am an energy and data analyst working in the social housing sector. I work closely with structural engineers for building site evaluations and condition assessments. My experience makes it easier for me to relay information to clients who may not be engineers themselves. My advice to you, as an engineer, your mindset is to problem solve in your discipline and always think on all sides of a problem. My second advice is careers do not have to be linear, and the ability to move, grow, and change makes you versatile in many environments. And third, learn the ability to network and volunteer for events to familiarize yourself with the industry and possibly find a mentorship. For groups like OACETT, you get what you put in. If you engage in the industry, you can learn to make a place for yourself in it. And for interview questions. For interviews themselves, and especially for behavioral questions, take your time and figure out what is the question they are actually asking. Are they asking for your weakness, or are they looking to see how you grow and overcome a weakness? Another question I encountered was, why are manhole covers round? Seems kind of funny, but it's so no matter which way you take it off or put it back, it'll always be in its right place. The idea with this is to design things in the most efficient way possible. Thank you for listening to my presentation, and I hope you have a great day.
Now we have a quick poll to conduct for the National Engineering Month from the National Engineering Month 2021 organizers. So Jürgen is going to distribute the polling. If you could please answer this, and then we'll move on. I see that the poll has closed. So thank you everyone for helping us with the poll. And before we move on to determining the winners of the first virtual engineering challenge for all ages, I just wanted to again thank all of the participants for their hard work and creative solutions. The York chapter of OACETT will be sending out an email survey after tonight's event, and we would greatly appreciate your feedback. And now, what you have all been waiting for. Who are the winners of today's event? Drum roll, please. We have decided that everyone that participated is a winner and will receive an OACETT prize pack, an M t-shirt, and a championship certificate. As well, since the COVID pandemic has been devastating on local business, we will also arrange for each winner, each participant, a $50 gift certificate to any business or charity local to them. We will be in contact with each of the participants to figure out the details and logistics. So it could be for, if you want, it could be a toy store, it could be a grocery store, it could help you to pay off your electricity bill. It could be for a donation to a local food bank or a local charity, but we will be in contact with you. So congratulations, everyone. I'm very proud of all of the submissions. Everybody did an amazing job, and you should all be proud of yourselves. Congratulations. And here are a list of the sponsors and partners without who National Engineering Month would not be possible. That is the end of the slideshow. Jen, are you there? Do you have any questions or anything that we need to cover?
Actually, nobody had any questions. Nothing came up in the chat. If you think of anything or would like to talk to any of us after this event, please feel free to give us an email or a call. At our best email to get us at is chair, so CHAIR at OACETT, OACETT-york.org. And one of us will get back to you.
Everybody that came out tonight, we really appreciate your participation. That me personally, that I've done engineering. So I please ask that you fill out the feedback form that we send, so that next year, and hopefully next year, it's going to be in person, and it'll be a much different experience. But thank you very much, and have yourselves a wonderful weekend.